Hey guys, welcome to the course of Computer Organization and Architecture. In today's representation, we will be talking about how can we represent real numbers in computer. In the previous lectures, we have discussed about how can we represent 7, -5, +5 with the help of sign representation and unsigned representation. But basically in our real life, that daily life, we basically deal with real numbers. So these are the floating point numbers, these real numbers. So these are some examples of real numbers. So how can we represent these kind of floating point numbers in computers? So we have two approaches to represent this kind of numbers. First one is a fixed point notation, and another one is a floating point notation. So where in the fixed point notations we have a fixed number of digits after the decimal part, okay, and in a floating point notation we have a varying number of digits after the decimal part. So in fixed point notation we have certain limitations, so we cannot represent a very large number, suppose 0.64 into 10 to the power 64 numbers, and also a very small number like a minus of 1.2342 into 10 to the power minus 36. So we cannot represent this kind of number with the help of fixed point notation. So we will represent this kind of number with the help of floating point notation, okay. And also the modern architecture basically use the floating point notation, okay. And let's talk about fixed point notation. So this is basically divided into three parts. First one is sign field, integer field, and fractional field. Just take an example as 1101.01. So in this example, the MSB, the most significant bit, is basically your sign bit. Okay, so this reserved for your sign bit, sign field, and this part is reserved for your integer field. That is your integer part. And after the binary point or radix point, this is your fractional part. This is your fractional field. Okay, and this point is known as radix point or binary point. So we can say that binary point is a kind of divider between integer field and fractional field. And now just take an example. How can you represent a fixed point number? Okay, the floating point number with the help of fixed point representation in 32-bit representation. So just here we have a 32-bit binary pattern, and basically we just divide this number in such a way that we have three parts. First one is your sign field, another one is integer field, and that is fractional part. So where in 32-bit we have 16-bit reserved for our fractional part, and 15-bit, this is your binary point, and 15-bit is reserved for your integer part, and the 1 bit that is reserved for your sign bit, that is your sign field, okay. And when sign bit is 0, that is the number is positive, and when a sign bit is 1, that is number is negative. And now just take an example of any number of fixed point representation. So here we have to represent minus 7.625 in 32-bit. Okay, so how we represent this number? So here this is your negative sign. So we have sign field is 1, and this is 7. Okay, so this is 7. How can we represent 7 in binary? We just write 111, and in the fractional part we have 0.625. So the binary equivalent of 0.625 is 101. And now just write down the binary pattern, and we have in the fractional part as 16 bits. Okay, so we have 16 bits, so already we just write 101 for 0.625. So we just write down 101, and the remaining bits become 0. And also for 7 we have 15 bits. Okay, so we have a 15 bits for integer part. So here that value becomes 111, and the remaining values, the remaining bits become 0, and the sign field become 1, that is your negative value. Now just let's understand what are the limitation of fixed point representation. Just to represent a positive value, okay, so what is the smallest positive number we can represent in 32-bit of fixed point representation? So here we have a 32-bit binary pattern, and since we have a positive number, so the sign field is 0, okay. And Now just write down the rightmost part as 1. Then this value becomes the smallest positive number in 32-bit. Okay, so which is equivalent to 2 to the power minus of 16. Okay, which is approximately equal to 0.000015. Okay, and now just know how can we calculate largest positive number in 32-bit. So just write down the positive, the pattern or binary pattern, and we have the positive number. Okay, so the sign bit become 0, and now the all bit becomes set, the integer part as well as the fractional part. Then we have to get, okay, then we will get the largest positive number in 32 bits. So in integer part we have 15 bits. So the maximum value in any bits. Okay, so we have n number of bits. Then the maximum value of binary value becomes 2 to the power n minus 1. So which is equal to 2 to the power 15 minus 1. In a fractional part, that is 1 minus 2 to the power minus of n, the maximum value. And which is, since we have a 16 bits, these are for fractional part, so which is equivalent to 1 minus 2 to the power minus of 16. Okay, so after adding these numbers we will get our maximum number, the maximum positive number. Okay, so which is equivalent to 32767.999847. that is approximately equal to this value, that is 32768. Okay, so we can see here that we have the smallest positive number as 2 to the power minus 16 and a largest positive number as this number. So we cannot represent a value which is greater than 32768, a positive value in 32-bit in fixed point representation, and also we cannot represent the smaller positive value than this number in a 32-bit fixed point representation. So these are the basically our limitation in fixed point representation. So beyond this limitation, we will have to study the floating point representation. So this type of problem we don't have in floating point representation, because there are no limitation of this kind of limitation in floating point representation. Also, we will discuss the floating point notation or representation in next lecture. Thanks for watching, and if you like the video on computer organization and architecture, so please do subscribe the channel, and God bless you all.